Hey guys, this is your trainer Anirudh Chhillar. So I'm back with another video of EIGRP. I hope you're learning in a good way and in good pace. Let's go.
Now let's talk about something named mode. Named mode. In EIGRP we are having two modes, classic mode and named mode. So we have discussed everything related to classic mode only. Now let's discuss something related to named mode. The very first thing in named mode that now for IPv4 and IPv6 you will not require to run separate processes. Before named mode it was mandatory to run separate processes for IPv4 as well as v6 stack. Are you getting my point? That before named mode it was mandatory to run two different processes for IPv4 and IPv6 protocol stacks, but in named mode it will be enough for you to run only one process for both protocol stacks. Second thing, in classic mode there was some problem related to metric calculation. Let me explain to you. Remember, the minimum delay that can be configured on your interface is 10 microseconds. Minimum delay that can be configured on your interface is what? 10 microseconds. And on all interfaces like 1 gig, 10 gig, 40 gig, 100 gig, default delay is what? 10 microseconds, and it cannot be lower than 10 microseconds, because when you configure delay it is always configured in the multiples of 10, and the lowest value in the range is what? 1. So if you will configure your delay as 1, it will automatically become as 10, because it will always be configured in the tens of in the multiple of tens. Now because your minimum delay is 10 microseconds, and previously to calculate your scaled bandwidth, are you getting my point? To calculate your scaled bandwidth, the formula was is not it in kbps. So if you are having link of 1 gig, formula will be like this: 10 raised to the power 7 means 1 2 3 4 5 6 7 divided by 1 gig, 1000 mbps, 3 more zeros kbps, so it will become 10. For 10 gig, 10 raised to the power 7 divided by 10,000 more 3 more zeros will also be there, because you have to define your bandwidth in kbps. So now it will become, for 20 gig, 10 raised to the power 7 divided by 20,000, because your metric cannot be, your scaled bandwidth cannot be in decimals, so it will remain 1. For 40 gig also, 10 raised to the power 7 divided by 40,000. So previously the smaller formula to calculate metric in classic mode was 10 raised to the power 7 divided by bandwidth plus total delay divided by 10 multiplied by 256. So if you are having a link of 1 gig, it will become 10 plus 1 multiplied by, it will become
56.
what? Okay, yes, it is 256. Sorry. Wait. Make it 256. So it will become
2762. 2816.
2816. If you are having a link of 10 gig, 0 plus 1, sorry, 1 plus 1, 512. If you are having a link of 20 gig, 0 plus 1 multiplied by, so it will become, if you are having a link of 40 gig, if you are having a link of so now let's assume that this is your router. This is having bandwidth of 40 gig, this link is having bandwidth of 100 gig. If it is receiving same prefix from both neighbors, it will perform with same matrix, so it will perform equal cost load balancing. However, according to the bandwidth, available bandwidth, for R1 its best path have been configured, have been elected that link which is having bandwidth of 100 gig. That's the problem. That's the problem with classic mode, that with higher bandwidth interfaces, if you are having higher links, then the formula of metric calculation would be failed. Understood or not? So this is the problem with classic mode. Finally, they launched named mode, and in named mode they launched wide matrix. If you talk about the wide matrix, the very first thing here, if you talk about the k values, you will be using k1, up to k6. However, still we are having only k1 and k3 1, and all other k values will remain 0. But here for different interfaces, like for all those interfaces who are having bandwidth more than 1 gig, for all those interfaces they have changed the formula to calculate their metric, because they will start to use your delay in picoseconds now. They will start to use your delay in picoseconds, and also they have changed your formula to calculate scaled delay as well as scaled bandwidth. And one more thing, in wide matrix now bandwidth will be known as like minimum throughput. There will be two things, minimum throughput and maximum throughput, and this maximum and minimum throughput will be depending on the available bandwidth. Delay will be considered as a latency. In wide matrix, in named mode, actually we will be calling delay as latency. Load will remain as load, reliability will also remain as reliability, and MTU will also remain as MTU. And the formula to calculate metric in named mode is this. Oh, sorry. This is the formula to calculate your metric in named mode. This is from here. Is it visible to all of you? Now it must be. Your formula will start from here and will end up to here. So in this formula, in place of bandwidth, now you are having minimum throughput, right? And latency means delay, load is still there, extended attributes are also there, and these extended attributes are energy and jitter. In wide matrix, they have also started to use some additional attributes as well for metric calculation, which are energy and jitter, which are known as extended attributes. But these extended attributes will be in use when you will be using K6. If K6 is already configured 0, because by default K6 is also 0, it means by default you are not going to use those extended attributes. And of course reliability is also there, see. And default K values K1 and K3 will remain 1, and all other K values are still 0.
So when do you use K6?
Whenever you will try or you will want to use extended attribute to calculate your metric.
So something related to the heat generated.
Jitter and energy. It must be specified here. And one more thing, in classic mode your metric could be 32 bits long only, but in named mode your metric can be up to 64 bit long. In classic mode your metric value could be up to 32 bits long value, which is by default up to 4.2 billion. But in named mode your metric can be up to 64 bits long value.
So result will come in 64 bit.
Yes. The resulted metric will be specified in 64 bits long value. You see, the formula to calculate your minimum throughput, where we are using bandwidth, is not it? So actually your throughput will be depending on your bandwidth, and this is the formula to calculate your throughput, minimum throughput actually. Latency for all those interfaces which are having their bandwidth below than 1 gigabit. The formula to calculate latency for all those interfaces which are having their their bandwidth higher than 1 gig. Any problem? Hello? If you are having any problem in it, please let me know so that I can explain it to you. So yeah, I was just telling you that it will be depending on the designer. It will be depending on your requirements in your network, right? So that, I mean, you can decide that which attributes should be considered to calculate your metric or not. So it's not always. However, Cisco recommends to use only these two K values, only these two attributes, or to calculate your metric, right? But still, accordingly, you can also make some changes. It's not always that I will be using or we will be using only K1 and K3 only. You can also use, you can enable load and reliability as well if it is required. Fine. So I hope that now you have understood that how EIGRP will calculate its wide matrix. So up to K6 you are having K values, and again here in place of bandwidth you are having minimum throughput. The formula to calculate your minimum throughput is very simple, 10 raised to the power 7 multiplied by 65536 divided by bandwidth. And the formula to calculate latency is this. But here we are having two different formulas for different interfaces. If your interface is having bandwidth of 1 gig or lower than that, is this. For higher than 1 gig is this. Adjusting EIGRP metric weights can dramatically affect network performance. Because of the complexity of this task, we recommend that you do not change the default K values without guidance from an experienced network designer. So I hope that now you have understood it, that how EIGRP is gonna to calculate its metric in named mode. Other tasks will remain same. The only difference will be commands, right? So now let's talk about the successor, feasible successor in named mode. It will remain same as previously. The condition of feasibility is same as previously. All other things will always remain same as previously, but here you are having some other features as well in named mode, like you can configure maximum prefix. You can configure your EIGRP in that manner, like I wanna receive maximum this number of prefixes from my neighbor. That was not possible to configure in in classic mode. Apart from that, in named mode you are also having like FRR, fast reroute, and this is really interesting feature of this named mode. So I'll be discussing it with you, but first of all, now let me start practicals of EIGRP in classic mode only. First of all, we will finish all practicals of EIGRP in classic mode, and then after we will repeat all practicals in named mode, because commands are bit different. Commands are not different, but the modes are different. So first of all, let's finish this classic mode and then we will go for named mode. So again, I'll be using same diagram which we used in red to perform all practicals of EIGRP. So by default, because we are going to implement this classic mode in iOS 12.4 first of all, and then after I'll be implementing named mode with using iOS 15.2. One another difference is also there in EIGRP in between iOS 12.4 and 15 is like by default in iOS 12.4 auto summarization is enabled, whereas in iOS 15 auto summarization is by default disabled. So these small changes are there in between different iOS versions.
iOS XE.
iOS 15 is having features of iOS XE. It is having features of iOS XE. That is why you are able to configure all these things here.
Same like
Same. Okay, let me know that have you understood everything which we talk about this EIGRP recently in previous class as well as in this class? Successor, feasible successor, everything, all these things, types of messages, their uses. Fine, let's configure EIGRP now in this network. So to configure EIGRP router, EIGRP is very simple. You can take any AS number here, but AS number must be same. So now say network 155.1.0.0. If here now you can use wildcard mask, right, to enable to enable the routing protocol on your interfaces. However, it was not possible in case of RIP. So in RIP, it was also possible to enable routing protocol on unwanted interfaces as well, but it is not possible to enable routing protocol on unwanted interfaces in EIGRP or in OSPF or in all these ICPs, right? It's not possible because here we can use wildcard mask. So is it really necessary for me to make you understand that how can you use wildcard mask to enable EIGRP on interfaces? With in network command, I hope that all of you are aware that how can we use wildcard mask. Network 150.1.0.0. Just copy and paste all these commands. I have not disabled auto summarization. I will show you that what will happen or what can happen if auto summarization is sorry. Again, there will be concept of contiguous and discontiguous only. Let's move on 64 now. First of all, it must have received all prefixes now. So it have received from 155's network only, which are contiguous networks, is not it? But it have not received anything from 150's range because now it have become discontiguous networks. And D2 auto summarization, because D2 auto summary, see it by default, of course, now we are using here discontiguous networks, so it performed auto summarization for them, and after performing auto summarization, when we received the same prefix, you see, so because in EIGRP there is also one another thing, that whenever in EIGRP you will configure any summarization summary address, it will always put that summary address inside its local routing table towards null interface. So because it performed auto summarization for 150's network, it performed auto summarization. Now it does not matter whether it configured that summary address dynamically or you configured it statically. If EIGRP is having any summary address, then it will always put that summary address towards null 0 on that device, on that device where you configured it. But this time you know very well that this router, this device performed auto summarization dynamically, automatically, and it calculated its summary address as 150.1.0.0/16. So it automatically put it on null 0 interface. So now whenever it will receive this update from its neighbor, because it is having its AD value as what? 5, and whenever it will receive this update from its neighbor, it will come with AD value 90. So to whom it will prefer? Which is having lower AD value. That is why it is not receiving the summary address coming from any other device this time. Hello, try to understand it. It does not mean that it is not going to receive this update inside the update packets. It will receive this update 150.1.0 from its neighbor device, but it will not accept it because it is already having this prefix available inside its own local routing table with AD value 5. Because it also performed auto summarization, and after performing auto summarization, it has put this entry towards null zero interface. Understood? Are you okay with this statement or not? Have you understood it, that why are we not receiving this summary address from our neighbors? Because all of them will perform auto summarization, will put this summary address towards null zero inside their routing table. They will provide that information to their neighbor devices, but neighbor devices are also having this prefix available inside their routing table already towards null zero interface with AD value 5. See, switch 2 has also performed auto summarization. Switch 2 is giving that update to this switch 4 now. But switch 4 is already having this prefix available inside its own local routing table with AD value 5. So it will prefer this entry actually. Understood or not? So this time it will be mandatory for you to disable this auto summarization. Let me show you that auto summarization is by default enabled. Router EIGRP 100, or it was 1. Say no auto. And now configure this command on all devices. See, show IP route. Have not yet received now all prefixes individually. And now from here you can trace route 150.1.9.9, which is switch 3's address. So it went to switch 2 first, then see, this is switch 2, R5, 3, switch 1, switch 3, switch 2, R5, R3, switch 1, switch 3. Now it calculated, you see, move on switch 4. It is also having one lane network as directly connected network, right? Show IP interface brief. Check it out. 150.1.10.0. Show IP EIGRP topology table, because it also forms topology table. So in this topology table you must get this prefix as directly connected. Let me show you. 150.1.10.0 is directly connected to this loopback 0, and its FD, as I said, that for directly connected interfaces also it will calculate its metric. Even you can also check it you can also check it for 155.1.108.0/24 as directly connected to the fast Ethernet 0x0, and its FD is what? 281600. Are you getting my point or not? So now you can calculate, you can check its delay as well as bandwidth. So delay is by default 1000 microsecond and bandwidth is what? 10,000 kilobits. So if you calculate, if you put it in Euler formula 10 raised to the power 7 divided by 10,000 plus total delay 1000 divided by 10 and multiplied by 256. So definitely it will come 281600. What's that? Definitely it will come to 81600. 10 raised to the power 7 divided by 10,000 means it will become 100 plus total delay by 10 . 1000 divided by 10. How much? 100. So 100 plus 100 is will become 200 multiplied by 256. So definitely it will become 281600. But it will be, I think, 1000. Yeah, it will be 1000, because if you divide 10 raised to the power 7 by 10,000, so it will become 1000 plus 100, so it will become 1100. 1100 multiplied by 256, then it will become 281600. That's fine. You can calculate it with the help of calculator. It will definitely, it will come same 281, same as 281600. Fine. Now because what? Yeah, on loopback also you can check its bandwidth and delay. So by default its delay is 5000 and bandwidth is 8000 80 mbps or 8 gig 8 gig, because it is 8000, so it will become 8 gig. So bandwidth is 8 gig, whereas delay is just 5000. So its metric, definitely you can calculate it, and it will become 128256. You can calculate it. Now because this is FD for ourselves, so for our device, if you move on switch 2, it will become advertised distance. Show IP. Let me show you. EIGRP topology. In brackets after slash value, it is advertised distance given by the neighbor, metric given by neighbor, and first value will always be FD. So you can see that AD is the FD of the neighbor, because for switch 4 FD was 128256 for the lane of switch 4. Fine, let's talk about EIGRP neighborship now. First of all, I will go for like how to change timers. I mean, let's perform some basic practicals of EIGRP. How to change K values, what will affect or what will be an impact on your network if you change its K values. So let me do one thing. Router EIGRP1 metric weights, then it will ask you about toss will always be 0 and only 0 is supported in EIGRP, and then after you will define your K values. So K1 is equal to, let's say, 0, K2 is also 0, K3 is 1, K4 is 0, K5 is also 0. So this time I am not using bandwidth for its metric calculation. I am not using its attribute bandwidth for metric calculation. Now neighborship has gone down due to mismatch of K values. So will it ever come up?
No.
If neighbor is not having same K values? That's what you are getting here, that neighborship is down due to K value mismatch. Over there they can do it, and they can also say no logging console. So you will never come to know that okay, why neighborship is down, because now on console it will never show you any log message. So in that case you can say debug EIGRP packets. So in debugging, in the output of debug also, you will come to know that okay, neighborship is down due to mismatch of K values, but here it is not showing you anything because I have said no logging console. So on console it will not show you any type of log now, whether it is debug log or syslog. Hello. Previously it was generating syslog messages, and when we enable debugging, it will generate debug messages. But now on console it will not show you any type of log message, whether it was debug message or syslog message.
So that's the end of today's video, guys. So we'll be coming back with few more videos of EIGRP. I hope you learned something new today. So if you like this video, please subscribe my channel. That's @ARC_tutorial. Thank you so much, guys. See you later.